Hi dear folks, today we are going to discuss about the quantity discount models. Quantity discount model is one of the three models for the independent demand. First is the optimum order quantity model or economic order quantity model. Second is the economic production quantity. Third is the quantity discount model. So there are three models which tells us when to order and how much to order for the independent demand. Independent demand is the demand for any product like marker, like fridge, like car, mobile. The dependent demand is the demand of the components of any product. So for the independent demand, we have three models. First is the EOQ, economic order quantity. Second is the EPQ, economic production quantity. Third is the quantity discount model. Let's discuss today quantity discount model. So what is quantity discount? Quantity discount, a reduced price for items purchased in large quantities. A reduced price for items purchased in large quantities. So you see discounts are everywhere. Whenever you go to any mart, any place to visit, you find the discounts, different kind of discounts. So when we talk about the discount, the quantity discount, it is the discount of the supplier, because supplier gives you a discount on the quantity. If you purchase a particular quantity, the supplier will give you a different price. So you need to decide whether which quantity you have to purchase. So it seems to you that the quantity you go for the least price, it makes a lot of sense to you, but actually it is not correct. Why? Because of your holding cost or the ordering cost. So you need to see that what is the correct quantity, what is the optimum quantity, what is the economic quantity, so that your holding cost and your ordering cost will be the least, plus your quantity of a product, your price of the product or amount of the cost of the product. So when we talk about the total cost to decide, it includes the product cost as well, along with the holding cost and the ordering cost. Let's move ahead. You see, this total cost formula is total annual cost. Total annual cost, that is TC, equals to annual setup or ordering cost, that is D by Q into S. D by Q is the quantity we ordered, D is the total demand, divided by Q. Q is the quantity ordered. So as what D by Q is the quantity we ordered every time. So you see, this is PD, annual holding cost, is IP Q by 2, and this is annual product cost, this is annual holding cost, and this is annual ordering cost. So all the costs we add in the total cost. So you see, P into D is primarily is need your attention. Why the product cost? Why the product cost is very important over here? Because we are getting the different prices in different quantities. So we need to compare them. So that is why we are taking the total PD into the total cost. So over here you see, Q is the quantity ordered, Q is the quantity ordered, D is the annual demand in units, S is the setup or ordering cost per order. Okay, Q, as I already mentioned, quantity ordered, I is the holding cost per unit per year expressed as a percent of price, P is the price per unit, P is the price per unit, D is the annual demand. Thank you. Yes, dear folks, you see in this graph what we have. This is the order quantity at the x-axis, order quantity, and at the y-axis we have the cost. We have the cost, total cost. That includes the holding, that includes the holding, the ordering cost, and the product cost. There are three lines you see: blue, red, and green. So first is the blue one is the total cost for the initial price, that has no discount. The red one is the first discount we get with the particular range of quantity. This is the third discount price we have with the particular quantity. So you see these are the three lines are there. Now you see the dark line, which is the black line, is moving from here to up till here. So it is giving us the lowest price in that particular quantity. So this dark line is giving us the price for the quantity, showing the quantity on the initial price. Initial price, for example, the initial price is 100. The initial price is 100. So this line you see, it is in the range of the this quantity from 0 to 120. It is the range of the initial price in which there is no discount. Okay, so you see this is the total cost. So it is maximum, it can be decreased up till here with the reducing of the ordering cost. It will fall over here. But when this quantity is above 120, the total cost would be decreased drastically because of the quantity discount. So you see, and this is the point in which we get the least price as per the economic order quantity formula. And you see the price is keep increasing up till here at 1500, and the price is increasing because of the holding cost. It is keep increasing. The 1500 is there, you see, and after 1500 the price is drastically reduced. Total cost is drastically reduced, and it is over here, and from there it is keep increasing. So you see, these are the possible 2 points where you get the least price, So what we do, first we try to find out the feasible this point where there is the least cost in any of the discount prices. So how do we get it? For what we need to do, we need to find the EOQ first of the maximum discount we are getting, the price of the maximum discount we are getting. So you see this point is not feasible. Why? Because the EOQ answer is EOQ answer is not within the range of this quantity. It is starting from here. You see 1500 and above. This discount is starting from 1500 and above. But our EOQ is telling us that above 120 only we can get the least total cost. So we we cannot take this because it is not feasible. So the second EOQ we will find out with the next, the second most least cost, least price you say. So when we try to find out the EOQ of the second most least price, we get this point, this quantity. This quantity is feasible. Why? Because this quantity is within the range of 120 to 1500. That is for the second discount range price. So we are done with this. We have found the feasible. We do not need this one. Why? Because it can never be lesser than that. Why? Because the price is high. Because there is no discount. Or if there is a discount, but price will still be high. Okay, if because the price will be high over here. So this is we found the possible order quantities. One is that this one, and the other one is this one. Let's move ahead. In this, how do we achieve the quantity discount model quantity? What we have to do, we have to start with the lowest possible purchase price, as I already mentioned in the graph, and in a quantity discount schedule, working toward the highest price, the second least price, we go with that. And 2 EOQ has to be found. The formula of the EOQ is 2DS by IP. D is total demand, yearly demand, S is the order cost, I is the percentage of the holding cost in terms of price per unit. Okay? This, through this formula we will get the optimum order quantity. Now we need to, lastly we need to calculate the total cost. So we will be finding the total cost of the feasible point plus the plus the next least price starting point, initial point. You see, we are looking at the example just to understand it better and apply whatever we have learned. Chris Banner Electronics stocks toy remote controlled flying drones. Recently, the store has been offered a quantity discount schedule for these drones. This quantity schedule was shown in the below table. Furthermore, setup cost is $200 per order. Annual demand is 5,200. Its an annual inventory carrying charge as a percentage of cost is 28%. What order quantity will minimize the total inventory cost? So we have been given the setup cost, that is S 200, annual demand, that is capital D 5200. Okay, the annual inventory carrying charge as a percentage of cost is I is 28%. You may take it 0.28 in the formula, and with that you go with the EOQ. So over here you see the price range. The price ranges are there because it is a quantity discount. So this quantity you have to buy for this discount, and the price per unit will be 98. And the second price you will get 96, and the quantity you will have to buy to 1500. So 100 has no discount. That is the initial price. When you get the discount, you have to buy from the 120 to 114.99. Third price we have to buy 1500 to over. You see how we solve this problem. As I already mentioned, the least price, that is $96, is the least price we would get in the price range. So with the least cost, we apply the EOQ formula. You see 96 is the 96 is the price per unit, and 0.28 is the I, 200 is the S, 5200 is the D, and 2 is in the formula. So we get the 278 drones per order. But you see $96, for the $96 price you need to be in the range from 1500 and above, but the 278 is under that. You see, 278 is lesser than 1500. This EOQ is infeasible for the 96 price. So now we calculate the Q hysteric for the next higher level. So in the next higher level, that is $98, we take out with the same formula, EOQ formula, 2 into D into S divided by I into P, that is 275. 275 is between 120 and 1499. So this is feasible now. This is feasible. This EOQ is feasible for the 98 price. Thus, the possible best order quantities are 275, the first feasible EOQ, and the other one would be the the almost the next range of the price. You see, the next range of the price starting from the 1500. The next lower price of 98 is 96, and its price range starting from 1500. That is also called price break quantity. The price break quantity is 1500. So we take the 1500 for the total cost as well. So there are the possible least points, possible order quantity we may have is 1500 and 275. So we will find the total cost of both. Over here you see the total cost, as I already mentioned, the annual ordering cost plus annual holding cost plus annual product cost. So we already know that the on annual ordering cost is D by Q into S. Annual holding cost is annual holding cost is Q by 2 into H. Annual product cost is P into D. So this is how we get this. We put all in this formula and we get on the this Q and this Q. So the Q are changed and the total cost is changed as well. So $517,155 and $520,053, the $520,053 and $517,155. Which one is the lesser one? So 517 is the lesser one. Thank you. Let's do this question together. Resolve the problem with demand 2000 and ordering is $5 and I is the percentage in terms of price. Initial price is $100. Discount price, the second price is $99. The third price we have the $98. So you see there are three different prices, and on the same question you will apply that with the same quantity discount. For the initial, you see 100, you just change the price. In the first price, in the first range you will put the 99, in the third range you will put the 98, and you just have to change the demand and the ordering cost and the I, that is the 50%. The holding cost is has lot increased. Holding cost has lot increased with the, because it is going to, but per unit holding cost is lot more increased. Like you are having the warehousing in the very busy city or the metropolitan city or the place which is very expensive. Okay, let's solve it. Let's see the answer. Only 20 units should be ordered each time, which is the EOQ at the 100 price. So over here you see we will not be availing any kind of discount. The initial price will be used. So you see how the things evolved. It is very attractive. It is very attractive that we go for the least price. But you see over here we are going to buy the quantity which is undiscounted, which has no discount at all. Why? Because the total cost is least. Thank you very much.